Now we're going to talk about adding a backup pump to our circuit. So we're going to use the same circuit as before, where we have two float switches and two pumps. But now, if one pump cannot do the job fast enough, then the second pump will also turn on and we will have two pumps pumping the water out of the tank to get down to the lower float switch. And then once it gets down to the lower float switch, it'll go back to the previous situation where the pumps alternate. So we're still going to use the if-then statement, the go-to statement. We're going to go to different subroutines. We're going to use variables. We'll be adding a variable this time. We'll be using the in statement, then the out statement. What we're going to add is timers and counters for the backup pump. So looking at our diagram, the same as the previous example with the alternating pumps. Just to refresh a little bit, the computer is going to send the software to the microcontroller. The computer can then be disconnected, and the microcontroller can work, as a standalone or separate from the computer, and can control the relays, taking inputs from the float switches and the output of the microcontroller, outputs going to the different relays. In this case, when the water goes up, lifts the high float, one or the other pump will go on. And if it takes too long for this lower float to go back down, after pumping, so the water goes up, lifts up this float. Let's say pump 1 comes on first. Pump 1 starts pumping, the water starts receding, or at least it should start. It should start going down, 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 until this here lower float drops. Then the pump would turn off. But if it takes too long, after a certain amount of seconds, and depending on what we put in the program, I put in this particular program we're going to see 20 seconds. So if it takes, by the time we get to 20 seconds and we don't reach this lower level, the second pump will turn on, and we'll have two pumps pumping the water out until we get to the lower level. And when the water goes back up, then we'll alternate, and then pump 2 will be the first pump to go on. So our schematic circuit, same as before, same as the alternating pump routine. We're adding, the backup pump ability to software. We don't have to do anything, through the hardware in order to get this, extra benefit. So that's the beauty of, dealing with writing code and having a smart circuit. We don't have to rewire the circuitry. We could go into the program and, update the program to get it to work differently. So here's our flow chart. Now I like to do a flow chart first to get a picture of what's going on, a roadmap, and this is our software over here, our program, or sometimes referred to as the code that we write in PBasic. As you can see, is the flow chart. The size of the flow chart increased a little bit, got a little bit more complex, a little bit more involved. That's why it's very important when drawing a flow chart to be neat. That's why I like using Excel. It makes it easy to draw the flow charts and keep it nice and neat. And let's take a look at what we added. So if I could just get my pointer options, and I'm going to draw a circle around what we added to the flow chart from the previous. excuse me. So this is what we added from the alternating pump routine. We added this pause 1 second, and I'll zoom in on this in a second. We added this variable k equals k plus 1. We added conditional statement k is greater than 20. Then we want to go to both pumps on, so we added this, putting both pumps on, that subroutine right here, and just like this. So this is what we added. We're gonna pause. We got a counter that's gonna count how many times we're gonna pause that 1 second, or whatever you want to make that to be. And we got a conditional statement here. If we went through this loop so many times, do we want to keep going, or do we want to put both pumps on? So let me zoom in on that section. And this here is the part we want to zoom in on, because this is the part we added. Alright. So here's a scenario. If pump 1 is on, we're not just, in the past we asked if the bottom float was down, and if it was down we shut off. But before we get there, we're going to just pause for a second. We're going to increment the counter, the variable k, and then we're going to ask ourselves if the float is down, and if it is, we'll shut off, and if it's not, well, then we'll ask ourselves, well, did we get, is k is greater than 20? In other words, have we been pumping for more than 20 seconds? And if not, well, we'll just keep, pumping with pump 1. And if we've been pumping with pump 1 for over 20 seconds, then we know that the one pump is just not capable of doing the job of keeping the water level maintained within a reasonable amount of time. So in that case, we need help. Pump 1 needs help. So then both pumps will go on. And k equals 0, what that does is that resets the counter, so that the next time we go through the program and we ask if k is greater than 20, well, we're not, k is not holding on to that value of 20. K is going to be reset here. Both pumps are going to go on. Bottom float is down, then we'll shut the pumps off. Up on top there, remember, both pumps shut off. The bottom float is not down. We just keep both pumps on, and we stay in this loop until that bottom float goes down, and we shut both pumps off. And just like in the previous program, the next time over here, because we're going to go to the other pump, and same thing, mirror image. I'm going to pause for a second, and increment k, and ask the same question here, mirror image. So no matter what pump is on, we ask the same questions to find out if it's been running for greater than a certain amount of time. If so, both pumps go on. So that is how we updated our flow chart, and then we do then we write the code, or write the program, which we have to the right. And so let's take a look at what we added, and I'm going to highlight with the highlighter what we see circled in this triangle. Basically is what we have here. So we added the variable k. The wet pump, we had that with the alternating pumps. So just review the alternating pumps if you're not sure about that. Let's see. Here we go. So we pause 1000. It means we pause for a second. K equals K plus 1. So that we keep count. Let's see. K is greater than 20, then go to both pumps on. Here's the subroutine, both pumps on. This is what we added. And the low 14, low 15, that turns both pumps on. Relays activate on a low. Pump 2, on pump 2 is same additions that we made to on pump 1. And when both pumps are on, that's where we reset the timer. So there we have it. You know, we got the pause, we got the increment the counter, we got the question. You know, if the counter is greater than a certain amount, it's greater than 20, and each pause is a second, that's greater than 20 seconds. We go to both pumps off, and I'm sorry, both pumps on, both pumps stay on until the level actually goes down. So I highlighted what we added. There's the added section. So what we have circled here in this triangle on the flow chart is what we added to the written code. And now we're going to take a look at what it actually looks like when it's pumping. We'll see a video of the pumps and the floats.